we are ready to start. So, welcome everybody to this first webinar in the Iliad webinar series. My name is Bente Lilja. I'm going to be your host in this webinar and introduce first a little bit about the content, then the speakers, and then finally we will have a discussion. But first and foremost, I'd like to introduce you a little bit to the Iliad project itself. And to help me do that, I will share my screen. And so the host here is Iliad, the digital twin of the ocean. And today we are going to learn about interoperability. It's an introduction to interoperability, and we are using the case of Iliad to teach you about the concept, but also show how we are addressing it in Iliad. The first presentation will be done by Piotr. He will give this introduction. Then we will learn about a very interesting GAIA-X system, the interoperability there. That will be given by Hauke. And finally, but not least, we will learn about discovering and sharing industry data from an interoperability perspective by Matthew from HubOcean. And like I said, the most important thing, I think, is to have a discussion. So we have about more than 30 minutes, at least, for a discussion. So we hope that you will be able to stay on. We start now at 2 o'clock, and the plan is to have the entire thing lasting 1.5 hours. So some housekeeping also. Please keep your microphones muted. Raise your hand when we have the discussion so we can give you the floor. You can also, of course, we encourage you to ask questions in the chat as you listen to the presentations, and we will address that in the discussion. We will also post some very small, easy to answer polls during the presentations, and we would appreciate you answering them to make us know a little bit more about each other and where we are with respect to interoperability. So that's the basic housekeeping. We will record the webinar, and it will be made available together with the presentations on the Iliad website, but also on several other partner websites. It's an open webinar and an open sharing of knowledge that we are doing here. So just very quickly, the context of interoperability is digital twins. And Iliad is one of the projects, Horizon 2020 project, where we are building multiple twins, actually thematic and geographically differently distributed. And key to this is interoperability. It's data intensive and cost-effective digital twins of the ocean we are building. And Piotr will talk definitely more about this. Again, Iliad in Seashell, Iliad will be a federated system of systems, and interoperability is key. We are also creating a marketplace and solutions to problems in society, but interoperable, as you see, is key. I mentioned that we have multiple thematic and geographically placed digital twins. Here you see the plethora, the wide variety of topics, from wind farms to insurance to jellyfish swarms to aquaculture and many things in between. Here are some facts. I don't want to go through it. These slides will also be shared with you, so you can learn more about Iliad by looking at the slides. So I'm the innovation manager in Iliad. I run a small company, BLB. I'm dedicated to sharing data, Earth observations, and to make them useful in society. And I will leave it to that before I now introduce the first speaker, Piotr Zaborowski. He is leading and managing the IOG Innovation Program initiatives in agriculture, marine, and building environment. He has been, you see, he worked on many different standards activities, and holds a Master of Computer Science from Warsaw, and he is fluent in the secure distributed systems for mass market and large-scale computations architecture. So Piotr will be giving you the introduction to interoperability in the context of Iliad. And the floor is yours, Piotr. You are muted, Piotr.
Yeah, thanks for this introduction. I hope you can see the big screen now.
Yes.
And yeah, I would just briefly talk about the interoperability challenges that we have in the Iliad project. Not yet about the complete solutions, as we are in the middle of the project on one hand, but also this is a first webinar in the series, and we'll definitely follow up with the other in-depth discussions. So Bente has already mentioned briefly about the Iliad. For those outside, maybe it's important to mention that we are building this digital twin for multiple end users, meaning that it can be industry, it can be research, which a little bit differs from the perspective of the service provision. And we want to scale up, we want to build and fit into the ecosystem. So what's the interoperability we are talking about? Is actually the ability to systems to talk to each other and to understand each other, which is quite important. And as you probably all know, it has different flavors. So this is quite mature model. It sometimes has 3, sometimes 5 dimensions, but here we have the technical and the organizational interoperability. And that all influence what we are doing, but yeah, we can a little bit influence also what's in the ecosystem based on our provision. So in practice, what we do when we consider interoperability is we think about some points of that concept, and we care about those because of different reasons. You can probably provide some more. I just mentioned a few. So, for example, we want to fit into the ecosystem, and as mentioned, we want to scale. We want to exploit what's available. As the uptake option, we want to exploit what's available on the market for our upstream. We all use off-the-shelf solutions, both as the software and as the services. So we are somehow limited. We can definitely build a point-to-point integration every time. Who forbids the reach, but we want to be cost-effective. So we really need to take care of the not reinventing the wheel and not rewriting every time the same thingy. And from our decisions that we have to make, we have on the right side the pilots and the use cases, and definitely they differ also. They have different scenarios, different actors, but they are really drivers of our needs. And we have also the aspects. Here, this is an example just from one of the reference architecture, the other one from the GAIA-X, but complementary. This is International Data Spaces Reference Architecture Model. And in fact, what we can see here is all about the interoperability. It's not only the first column, which is what we call technical interoperability sometimes, but the identity management, the trust that we are building around the services, the governance in the end, and the service levels that we want to achieve. All of that shall be interoperable in the middle to expose that on the endpoints. So, yeah. And yeah, standards are just a little bit helping and serving those needs in the harmonized way. So they prevent the degradation of the services and of the interoperability between them. They also help to recognize some compatible components, but most importantly, just limit our costs when we build the solutions that integrate with multiple assets. So I have a pool. Vote. So everybody needs to vote now to see the screen again. Just briefly, if this is the value stream that's proposed by the BDVA, and what's just meant to be mentioned here is that we are covering most of that with our actors. If somebody cannot see oneself, just speak out loud during the discussion, because this can be misunderstanding of our roles, but here we are covering everything, which means that actually our customer is also everybody in that loop. And then we have our Iliad environment. We've mentioned that this is a digital twin, so it provides this functionality that's a little bit in addition to the spatial data infrastructure, as we know that from the previous years. But again, we have the data providers. They are different. They are various. They are inside of the consortium and outside. We have the data spaces that we integrate that data together. And we have the core when the simulation can happen, and it can run different applications, which will influence us in a second. We have to challenge the findability. So we have the challenges also on the top. This is, for example, the findability. You have to have a catalog of the things to find, and you have to provide the functionality to query. You have to find the data you want, you have to find the services you want, and you have to recognize if this is suitable because of the licensing, some service levels, the quality that you want to achieve. And naturally, you have also the human interface. In between, as we want to calm that architecture, we define those interoperability points in here in yellow, and we have that both on the input and the output of the data provision. And what's important here is that here we can have multiple sources in different ways. So when it comes to the data spaces, we are really mashing up different types of data, which means both the information integration and also organization, because the storage that we have sometimes influence the way that we are providing the data efficiently and vice versa. So we may need some additional infrastructure if needed for our cases. For example, here we have a lot of the netcdf files which are used by the pilots, and we want to expose them both as the files and as the APIs, and we need to do that efficiently. And the digital twin core, which I called here core because this is again the execution of the simulation. And in here we have also different type of the interoperability. So we can have some little storage on the engine, but usually what we are doing is referring to the external or some URI data that can be briefly everywhere. And on the bottom, we have also the containerization infrastructure, which means we want to have the ability to run different applications on that infrastructure. And we want to have the ability to open that infrastructure for our network and our partners in the project and outside to have these added products available. And again, the interfaces of the front end are linked mostly to everything. So as we said, we need to have the data that's loaded into the simulation, but we also have to have the lightweight version of the data that we may need to visualize on the front ends. That's what the cloud native movement is doing also, but also the APIs approach in general is familiar with that. I'm guessing I'm coming to the end, but yeah, I have a few minutes. So if we consider the reusability constraints, we haven't solved yet on the previous slide the information level integration. Just talk about the transactions. The information level integrations mean that we understand what the data is. And in particular case for the Iliad, we may need to know what's the sensor accuracy, for example, or what was the model confidence that we used. Not only, but we are solving this with the semantic harmonization. I guess there will be next episodes talking deeper about the HubOcean information model that supports that as this information backbone. But just to mention, this is the semantic interoperability challenge that we also need to solve. And with all of that said, that about the spatial data infrastructure for the open data, we want to provide a marketplace, which brings yet another few interoperability points. We have the EEE, authentication, authorization, and access, but we have also service policies and the procedures of the registration. We have to take care of the quality and quality assurance of the data, of the services, and naturally the service levels of every component that we offer, especially not for free. Then we want to fit into the larger context. So we are aware of what's happening in the European perspective, both from the public and from the industry. We will follow up this discussion with the GAIA-X. The idea is quite common. We want to build the common market that's federated, that provides the data access and service access. It is supported by the vocabularies. Just to mention, this year we are also starting the working group between JRC, ISO, and supporting that from the Open Geospatial Consortium side to provide the guidelines how to do that. I believe that with the Iliad, we can provide a lot of the use cases for the GAIA-X. As far as I know, GAIA-X is highly driven by the use cases. So we can probably provide some use cases, or we can also implement some of the use cases and propose that to GAIA-X. And here's a high-level relationship between what I presented on the, let's say, component level and on the GAIA-X architecture. So we both have the data spaces. We actually both have services, because what we call the digital twin applications are the services. We have that identity and trust on the bottom as the access point in the marketplace, as well as the compliance. And we have the catalog, which is also federated in GAIA-X. For us, we are actually building catalogs that will harvest some of the data and will also combine it as the federated one into the one space. And with that say, I guess I'm out of time, which is fortunate because I'm open for your questions.
Thank you very much, Piotr. That was a very quick overview and introduction to interoperability.
Yeah, I had only 20 minutes.
Yes, yes, very, very nice. I will, before we go further, first of all, questions for clarification we can handle while we are presenting the results of the poll, and then keep your questions or post a question by all means in the chat. But we can have a discussion so that you can ask Piotr in more detail in the discussion part, because there might be many, the question might go in many different directions. You ended on a very appropriate note because you were, pointing to GAIA-X, which will be the next presentation. But now I want to share with you the results. I think I can do that. Can you confirm that you see the sharing?
Yeah, we can see it.
Yeah. So we asked, what is the main challenge of interoperability for you? And you answered that the complexity of standard landscape is the major challenge. The second biggest is semantics. And then we have software availability and non-technical aspects. So I thought that was interesting to see what the audience found to be the most challenging. Or we did collectively, and we will collect this information, by the way. So I thought this was a quick sharing of the poll. I will stop this now, and then we can go back to, yes, the screen. I also wanted to mention, by the way, thank you to Katja. I didn't introduce Katja, and also I want to introduce Andre, because they have been, they are sort of behind the scenes helper here. So Katja, you can say hello.
Yeah, hello everyone. Thank you so much for introducing. I also would like to, maybe meanwhile we can start like the first poll we supposed to start at the beginning of the webinar, because you went in your introduction to yeah, so I think that I can launch one more poll. So
okay, yeah. Yes, that's interesting. The more the value of the interoperability you can see here.
Yeah.
And I think I can share my screen while the poll is open. Let's test, because I want to introduce Hauke. I'll do that. Let's see what happens. Katja, this is a live experiment now.
Yeah, it works.
It works perfect. Hauke, you are next up. Hauke Ernst. He is driving digital transformation in the space system division in Airbus, Defense and Space, placed in Bremen, Germany. He's focused on the customer interface, and he is currently leading a major flagship project for Airbus in the context of artificial intelligence and cloud. One of them is what we're going to be learning about now, GAIA-X Corporate Program, and is aiming to establish a new data ecosystem for aviation and space based on GAIA-X. So Hauke, the floor is yours. I will unshare my screen, and we are excited to learn about GAIA-X.
Okay, thanks. Can you hear me or not yet?
We hear you.
Okay, perfect. And you also see my slides?
Yes, we do.
Okay, perfect. Can you still see it?
Still.
Okay, thank you very much. So as you see on my background here, I'm more the space guy and not the ocean guy. I apologize for that, but we all know, and we have seen that also in the previous presentation, there's always links between these worlds, because there's a lot to see from space in the ocean or in the coastline and so forth. And I think it's super interesting, and there's a lot of overlaps we can talk about. Digital twin is obviously a major topic in our domain as well. I come to that. So the project I'm talking about today is called Corporance. It's called Collaborative Processes and Services for Aeronautics and Space. It's a project that is funded under the umbrella of GAIA-X by the German Ministry of Economy and Climate. It's about 20 million euros, this one. And it's a co-funding scheme between industry and the ministry. So also Airbus has some stakes inside. And the background is that typically we are building spacecrafts, complex spacecrafts, also obviously aircrafts with similar problems of interoperability. And we are not only building those, but we also run missions with them, which deliver data, which could also then be of interest for Earth observation and ocean topics. So I think that's why I think there are strong links between these topics. Here's just an overview of our consortium. We see that we have collected industry, research institutes, SMEs, and startups. So there's Airbus inside, but we also have our competition with OHB, for instance, also incorporated. We have 4 or 5 different DLR institutes and many other actors in our consortium. And we are tackling mainly interoperability topics with our project. As I said, the project is funded under the GAIA-X scheme, so I will come to that link later. But the problems we are facing is, first of all, organizational interoperability. So the landscape we are dealing with is complex. It's not that just one party is building a spacecraft. It's many different actors who need to work together, also with our customers, with ESA, for instance, or the European Space Agency. And a lot of heterogeneous landscape is to be organized to build such kind of space mission. There's also connected to that technical interoperability. So many different tools, many different data models, various standards which could be used. And per se, what we do in the past is to exchange documents. So previous times it was paper documents, which was shipped in containers to the customers. Now we ship PDFs, but it's still documents. So here you see a lot of value to change to a model where we can really work together on structured data, on structured models. And that's why also this whole topic of having a digital twin of a spacecraft comes into the game. And then the third one is that the ecosystem we are dealing in is more or less a closed environment. So that there are always the typical suspects to work with for certain types of equipment and so forth. And it's hard for newcomers to come in, which is also a problem because this is not so helpful to get innovation into our industry, working with startups and open, let's say, open the community to newcomers. That's another problem we are facing. Coming back to this first problem of missing organizational interoperability, there's 3 bullets I've put here on the slide, which are kind of related to that. One is that there's not really a governance framework and standard available to help this organization. There's not so much available on overarching framework agreements and so forth. There's always just a project to be done and that's it. So not so much available for long-running collaboration, data flows and stuff like that. And then we have the problem of long lead times for certain equipments, multiple iterations being needed and so forth. For the second problem with the technical interoperability, as I mentioned, there's a lot of paper processes or PDF-based interfaces still be there. And if they're structured data exchange, then it's basically uploading for some files or manual interfaces to be served. And here we see a lot of potential to work in this kind of GAIA-X or data space environment to make improvements in this area. We also are suffering a lot from inconsistencies and misunderstandings which come from the lack of such kind of interfaces because the manual transfer of information from one system to another leads to some errors and other effects. Yeah, so let's say regarding the business partnerships, we have heard in the previous presentation already the topic of maybe having a marketplace. So this is something that we also are really looking at and today suffering from the fact that this type of thing is not yet existing. And this is what we want to work on. So I jump to this slide, which is also something that was on the previous presentation, but now it's a little bit bigger to explain a bit more on the principle of GAIA-X. So GAIA-X is really a federated infrastructure. So it's not one cloud that is hosted by somebody where all the data needs to be hosted. It's really a kind of framework stuff that is there to bring together federated computing nodes and data centers and services into one logical ecosystem where data and services can be shared. To do so, there's a lot of things that you need to do. You need to establish a kind of identity and trust framework where you can use your identity that you create once for many different purposes and to consume data, consume services, and so forth. Having a kind of catalog, so a meta information, which data is available, which services are in place, and where to find them. That is another element. Some data policy and governance and compliance rules is been defined in GAIA-X. And the whole thing is also made to ensure data sovereignty regarding the ownership of the data. So obviously the owner of the valuable information wants to keep in control of their ownership. Sometimes the data is also attached to some monetary value, so that people want to earn money with their data sometimes. And obviously the data is valuable and needs to be protected. And that's why GAIA-X is also a kind of European approach, let's say, to as an answer to the US Cloud Act and the US Patriot Act, where the US government can have access to private information and so forth. And that's why also GAIA-X was founded, to create this kind of sovereignty of the data, where, for instance, US government cannot access all the stuff, and this kind of cloud infrastructures that are coming up can be really used to commercially work together on data. So that's why in GAIA-X, the attempt is to create data ecosystems and data spaces which are federated and distributed over many different nodes and ensuring interoperability. Coming to this one here, and the Corporans project, as I said, it's the flagship program that is funded for aviation and space. And here we want to define a governance for our industry, a governance to create such kind of data ecosystem. And we also want to develop a technical foundation for this data space and establish a first version of a marketplace where such kind of services and data can be published and consumed. This here is an overview. You see this data space and data ecosystem is in the middle. The key actors in our domain would be, first, we have a lot of research institutes. We have the primes, so the OEMs like Airbus and OHB or Thales, who, let's say, are the prime, typically the prime contractors with the customer and organizing all the subcontractors, which are also part of the ecosystem. So we have the subcontractors, the equipment providers, but now we have also the pure software providers, which provide digital tools, innovative solutions, and so forth. We have the agencies as our customers, and we also have the data consumers. Not to forget, and I understand that in your environment, where you talk about the ocean, you're also dealing a lot with Earth observation data of the ocean. Obviously, from the spacecraft, we are delivering such kind of information, and this could also be part of that whole GAIA-X ecosystem. So with this, we can also see that there's even bridges between different data ecosystems, where we might have one for kind of building the space product, and another one for maybe making sense of that for ocean purposes. So, and that's where I think GAIA-X can bring a lot of value to really mediate this kind of bridges and federated infrastructures. For our project, we are mainly dealing with collaborative engineering, where remote people, remote teams can work together on models, so-called a kind of digital twin of the spacecraft. But there's also, as I said, the perspective to also incorporate the data provisioning from the spacecraft into these ecosystems. And here I have two examples of the Pleiad Neo mission, where we have imagery from satellites of 30 centimeters of resolution. And obviously, a new way to promote this kind of data would also be through GAIA-X ecosystems and data spaces and marketplaces. Okay, coming to the end, I guess my time is already over. Just to mention again what would be the main results of our project. It would be finished by the end of 2024, and we want to have an implemented first version of the ecosystem with some example services being inside. We want to validate that with concrete space pilot missions to show how it works and to demonstrate the value. And we also want to use it as a lighthouse project for further scaling of the model. So that's why I'm very interested in discussion also how we could link this story to for instance, your initiative with the digital twin of the ocean, because there's a lot of links that I would see, and I'm really happy to have opportunity to discuss that. Okay, thanks a lot, and happy to answer questions.
Thank you very much, Hauke. This was a very nice overview, an introduction to GAIA-X in general, not only for the space and aviation sector, I think. But the space and aviation sector has an interest, and we can come back to that also for the ocean twins. I want, before we go on, please write questions in the chat and or spare them to the discussion after the last presentation. Meanwhile, before we give Matthew the floor, I would like to share with you the results of the poll we posted while Hauke was speaking. And you see them here. The question was, how do you think, what do you think about GAIA-X? How do you think about GAIA-X? Yeah, no idea. Want to investigate deeper, could enable faster development of digital services, could create a new sales channels for data services, could create a new sales channels for software services. I posted this poll after you were finished with the overall view of GAIA-X, Hauke. And you see that there you actually reached some new potential clients, I guess. And there were some that hadn't heard about it, but most people want actually to dive deeper. So I think this is a good starting point for our continuous dialogue afterwards. Yes. Okay. So with that. We will, Katja, did you save the answer to this poll?
Yeah, I see the poll answers, and yeah, Anne is mentioning that poll amount is more than 100% is because people can choose multiple options. Oh,
okay.
Yeah.
Yeah. Thank you. I stop sharing now this poll, and I will go back here and introduce Matthew. So Matthew is going to talk about industrial data. And he works at HubOcean, one of the Iliad partners. He works with industry, particularly creating data sharing flows in the energy sector. We have ocean energy is one of our thematic areas in the Iliad. He has a background that bridges both science and businesses, and he is going to talk about how HubOcean is working on industrial data. He has experience, accumulated experience from oil and gas exploration, the marine data acquisition, and developing data science applications, creating products, and consulting and project management. So you have a broad background, Matthew. So we are looking forward to learn about how you are dealing with industrial data in HubOcean.
Thank you, Bente. I'll just get my screen shared. I hope you see that okay there.
Yes, we do.
Great. So yes, I'm going to tell a slightly different story to the previous two presentations, which is less focused on the sort of let's say technical aspects and more on what interoperability can do in this domain of discovering and sharing industry data, which is something we're very passionate about at HubOcean. We're also involved in the Iliad project as trying to deliver on the interoperability aspects, but I'm going to talk a little bit more on this other work and why it's relevant to interoperability. So first, a very quick introduction for those of you who don't know so much about us. We're a non-profit foundation based in Norway, and we're really part of multiple different domains, really. We're founded in a sort of industrial group in Norway, the ARCA group. We're in a network in the World Economic Forum, but also parts of kind of scientific and intergovernmental initiatives, you know, working closely with the UN Decade, the high-level panel for sustainable ocean economy, and of course, a proud member of the Iliad project. So, you know, we're really working to, what we say, unleash the power of data for ocean health and wealth. And we're doing that by trying to bring together different data sets, much like you've heard in the ways done by others here as well, bringing together open data, dispersed data, which maybe is like research data that's in focused areas, and industry data, which is perhaps more locked away, private, not shared so widely at the moment. We're bringing that together. We're also creating an ocean data platform as a way to interact and use data in the cloud, and to bring this data together in one place, and well, not just one place in the world, but bring it together so it can be used within our infrastructure and without it, and outside of it, and to be used by multiple people, multiple different user groups in multiple different ways for lots of different use cases. So we're going to focus here on, like I say, the industry data, but already from this schematic, I would just like to highlight, of course, that interoperability is sort of critical to the success in multiple ways. It's critical to make sure that data from different sources works together. It's critical to make sure that different data types work together. And it's critical to make sure that data is used in as many different ways as possible, that it's harnessed to its maximum potential. But first, I think it's always important to frame what we're talking about, because people have different ideas what we mean by this. But industry data, you know, first of all, in this context, we're focusing on, you know, of course, ocean data from mainly ocean industries. I'm going to take examples mainly from the oil and gas sector and the offshore wind domain, but of course, there's many other opportunities and options here. You saw all the different pilots and twins being developed in Iliad through aquaculture and water quality and all sorts of different industries, shipping, you know, and we work across many of these. But if we focus on that, we can divide in oil and wind, we can divide into, say, the very industry specific data. And this is stuff in the oil industry, like the subsurface data, seismic data, production data, well data. And on the wind side, it's the local data, like the actual wind speed at the turbines, the power generation, the turbine performance. So that's one sort of one category of the data. And the other side is all the other data that you need simply to operate and work and have installations that are in the ocean environment, and to do that sustainably and effectively and safely. And that's all sorts of things like environmental surveys, meta-ocean measurements, and all sorts of others. We'll go more into that. But really, there's this whole host of sort of secondary data that's needed, and that's our main focus here. I'll take examples from that first set as well, the industry specific, because it's just useful context and good examples. But these are both very interesting. And then why are we working on this kind of data? Well, we believe that there's you know, a real potential for this data to bring a lot to the world in many different ways. If you look at the snapshot of the North Sea, of the different licenses and the different installations that exist and have been in the North Sea, they're pretty numerous and spread over the whole sea. When we're talking about twins and analysis and really taking you know, science and all sorts of things to the next level, then we want data from more places, more sources, more data. This all contributes to what we want to bring together into these digital twin and different infrastructures. When we talk to oil and gas companies, then even if they exclude all of the kind of primary data like seismic data and costs like this, they tell us that they've spent vast quantities of money acquiring this other data that they practically don't use, but they have spent that money, it's been acquired, and we think that there's value in a lot of it if we can find the right ways to get hold of it and get people using it. So I'm going to just talk through a few examples here to illustrate the situation a little bit. And first, I'm going to start with oil and gas data on the business critical side. And now we're not trying to get hold of this data or really use it in it like seismic data in our platform. But I think it's a really interesting example because you might think that this data is so sensitive and never used and more difficult to share than any other type. But because it's so valuable and it's used so widely, actually it has fantastic standards, comprehensive regulations. It's very easily shared between different companies and authorities. So it's actually a huge investment into the sharing of that data. The problem is actually when you go to the data that's less valuable or less known about, and that data hasn't had the same kind of treatment. If we think about offshore wind, which this is just stick. I need to answer the poll. Okay, there we go. If we think about offshore wind, then it's a more immature industry. It's growing very fast, but there's still some really interesting examples. This is wind data that operators had to share with the Marine Data Exchange in the UK, and by sharing that, a company, TGS in this case, took that industry data together with public data to create an improved local wind model. So that's a sort of nice closed loop where industry has shared some data, it's been brought together with existing data and to create an even better data product, which actually then benefits industry again and others in the same domain. It's quite a neat little example of the kind of synergies you can get from sharing data. But then, as I've mentioned, there's all this other sort of data we're talking about. Sensors on installations. You saw that map densely points throughout the North Sea. All of these are potential opportunities to measure data and share data. And the existing state of this is really very scattered and mixed. There is some data sharing from some companies in some contexts, but it tends to be very kind of project by project. It's not universal, it's not coordinated. And really that kind of takes away the main value of it. The fact that if you had this coordinated attempt to get this data, you would really have this really fantastic network of sensors and arrays that you could use for all sorts of fantastic applications. And the final one here is kind of more sort of survey data and monitoring data that perhaps is done periodically. That's things like site surveys before installations, ecological surveys. And again, some of this is released. There's some regulations requesting that data, but it really often falls through the gaps in these industries because it's not the primary data that they work with on a day-to-day basis. Sometimes there aren't data managers who are actually assigned this data to look after it and make sure that it is used and that it's described and that it's possible to share. And in addition to that, there's also this sort of secondary data, and this is other things that we're working on now. So when there are ROVs doing monitoring operations and installations, there's all sorts of other data that could be acquired in the same loops, measuring current data and things like this. We've had some very clear messages from sort of ocean modeling scientists that one of the things they lack the most is subsurface data because they have quite good control at the sea's surface, but at the sea bottom, it's much harder. So, getting data from these monitoring from ROVs that are doing sort of sea bottom surveys would be really valuable. So, yeah, just to mention, these bottom two that we at HubOcean are really focusing on here, getting sensor data and surveys. And we are establishing pilots to test out different ways of doing this in different contexts for this, because I think whilst there are examples of it. It's quite an immature domain, this kind of data sharing. It's not so coordinated, and really we need to kind of raise this and try and overcome some of the barriers to get more data shared. And that, you know, that's a sort of complicated topic that I could spend a lot more than 10 minutes talking about. But you know, some examples, and in addition to all of the ones I want to say now, there's legal concerns and commercial concerns and all this other stuff. But just purely practically, often companies don't know what to share. They don't know what use cases exist, so they don't know why they would do it. There aren't standards for them to share. It's very ad hoc, that, you know, one research institute gets one set of data. The ownership is very fragmented. So all of this means that interoperability isn't really invested in. The data isn't described so well. You know, this whole thing fits together. Use cases then are harder to find because the data isn't interoperable. And this cycle continues, really. Regulations aren't put in place, so, you know, people don't know what to share. So really, we need to break through some of this stuff, and we need to identify very clearly what data exists, how to share it better, and why to share it in the first place. And you know, the main ways that we can go about doing this is getting more examples of data that are valuable, making it easier to share that data, make it easy to access that data, and use it for a wider range of purposes. And really, this is at the heart of interoperability. And then using that in a way that shows why it was good. And I think the more times we can tell these stories, the more times we can prove this data, I think the more data we will manage to unlock and be able to use for all sorts of great purposes. And I'm just going to end by mentioning some of the things going on in the Iliad project that are very relevant to this. And I think, you know, there's lots of things that can contribute to all of these elements. There's work to get better data exposure from industry, so it's easier for them to do that. Better interoperability with Ocean information model, better discoverability through the data and services catalog, and better demonstration of these values. So, you know, Iliad has the potential to do a lot of great things in this domain, and yeah, so it's a very exciting time. And that's really that's my 10-minute message for today. And I'm just going to end by saying thank you, and leave you with a little call to action here, which is those 3 questions I ask about. I think we really need to make sure that when there are good examples, that we tell them and that everyone knows about them.